Hello everyone, welcome to the Booster Shot, a daily dose for your GS preparations. This show is brought to you as a courtesy of Raj Malhotra's IAS Institute, Chandigarh, and is presented to you by me, Ayush Gupta. So, by means of this very show, we cover up three important segments of the news cycle, which are the big picture debate of Rajya Sabha TV, the Indian Express's explained section, and the science monitor of RS TV. Why we have selected these three segments is because these segments not only cover issues of national and international importance in depth, but also provides us with succinct information and with perspectives. What is required to ace this examination is not just expanding our sources of information, but the key lies in curtailing of our sources of knowledge, which is the chief reason why we have selected these three segments. So, let us move on with our episode. This is our second episode in line of this show. So, in today's episode, we are going to discuss yesterday's Indian Express's explained section, which dealt with the GSLV F10 failure that took place 2 days ago. This was a GSLV Mk3 rocket carrying an Earth observatory satellite to space, and we are going to see what are the key takeaways from this failure. I have summed up this discussion into this question, which is: state the difference between GSLV Mk2 and GSLV Mk3, and also how this failure of GSLV F10 is going to impact upcoming missions, namely Gaganyaan, Chandrayaan 3 and Nisar. So, let us try and answer this question. But before that, we need to see a brief history about GSLV. So, GSLV satellites, GSLV launch vehicles are basically vehicles which can support heavy payloads. Why India required these launch vehicles is because of the increasing need of our telecommunication. In 1990s, India felt this very need. There was an increase in telecommunication requirements, and we entered because we did not have the technology to send off to make such vehicles which can send such heavy payloads. We got into an agreement with a Russian agency, the name of which is over here, and this agency, as per the agreement, was to provide us with technology with respect to cryogenic engine. What are cryogenic engines? Cryogenic engines are those engines in which liquid fuel can be stored at very extreme low temperatures. Mind it, it is low temperatures, and this engine provides us with the maximum thrust in order to lift off heavy payloads. So, however, after this deal went into rough waters. For 15 months, our 8 scientists visited the Russian agency and looked at the working of cryogenic engines. However, this was objected to by US in no time, and the US objected this on ground of us not being member of MTCR, which is Missile Technology Control Regime, which was made to prevent spread of complicated missile technologies. The US said that India will use this technology at that point in time in 1993, in 1990s itself, that India will use this technology in order to make intercontinental missiles. India although denied this at that very point in time. So, we were left with no other choice. The Russian agency backed off in 1993 completely, and they gave us ready-made cryogenic engines, but did not fulfill its promise of making us capable of transferring the entire technology with respect to making this cryogenic engine. However, Indian scientists tried to reverse engineer Russian technology and ultimately came up with GSLV Mk2 and its first test flight was in 2001. It met with its last accident in 2010, when again this flight of GSLV Mk2 was unsuccessful. However, after that it had completed roughly 6 missions and it was successful till then, but now again this problem with this GSLV Mk2 has resurfaced. When it comes to GSLV Mk3, it is an advanced version of GSLV Mk2 only. However, in this very case, the cryogenic engine is developed by India, not Indian scientists, not by reverse engineering Russian technology, but it is a result of about 3 decades of efforts and inputs. And this very engine, which is the GSLV Mk3, a picture of which I have brought out for you. So this very engine is the cryogenic engine's design is based more on the Ariane rockets of European Space Agency. This class of rockets were basically used by India to send off heavy payloads from French Guiana. So the design is more or less based on Ariane rockets, and therefore Indian scientists have more control over this very technology in GSLV Mk3. Also, the system to ignite the fuel in this cryogenic engine is different from Mk 2. So Mk 3's system to ignite the fuel in cryogenic engine is different from that of Mk 2. I have put out the images of both these rockets. Let us just examine them briefly. So basically both of them are 3-stage rockets. So the first stage, we have 4 strap-ons over here. One is at the back side, and these are liquid propellants. Jabhi bhi there will be a launch, this will be the first one to start the launch. Second stage, we will have Vikas engine, and in the third stage we have the cryogenic engine. Over here it is the payload. So cryogenic engine के अंदर जो fuel है, the fuel's formula of cryogenic engine is over here. It is LOX plus HLH2. The maximum weight the GSLV Mk2 can take to geostationary orbit is of 2500 kg of payload, and in lower Earth orbit it can take satellites of up to 5000 kgs. Coming to GSLV Mk3, again a 3-stage rocket, 2 strap-ons at the first stage. These strap-ons, although are carrying solid propellant against the liquid propellant that we find in GSLV Mk2. Then we have an improved version of Vikas engine again over here as our second stage, and then at the third stage we have this new cryogenic engine. So this cryogenic engine can carry up to 28 tons of the same fuel which is being carried in GSLV Mk2. So this is the difference between both the satellites, both the rocket launches. Moving forward, so how this failure is going to impact the Gaganyaan, Chandrayaan 3 and Nisar. So basically this failure was attributed by the ISRO's chairman to the technical anomaly observed in cryogenic engine, ignition problem at the last time. So in 2010 also this problem was seen, and however after that about 6 missions have been taken up by GSLV Mk2 successfully. So what is the impact going to be on the already delayed calendar of ISRO? The key projects are the Gaganyaan, which is India's first manned mission and which is scheduled for 2023, and then is a Chandrayaan 3, which will be a repeat of Chandrayaan 2. However, only this time Chandrayaan 3 is only going to have a lander and a rover and not an orbiter, which is scheduled for launch in 2022. So both these missions are to be launched by GSLV Mk3 and not GSLV Mk2. So there will not be any direct impact on their launch time frame. However, there is a possibility that GSLV Mk2 might be used for some preparatory flights or for testing some technologies with respect to both these missions, especially in case of Gaganyaan. So over here there is possibility of some problem. However, when we are going to talk about Nisar, which is a collaboration between NASA and ISRO, there is a bigger issue ahead. So basically Nisar, the full form of Nisar is NASA, ISRO and SAR. SAR is synthetic aperture radar. Basically this mission is going to set up 2 radars in outer space, and this will be an L-band radar that will be supplied by NASA and an S-band radar which will be supplied by India. As per the collaboration, ISRO is to supply with the launch facilities and the launch vehicle, and it was decided that GSLV Mark II is to be used in the launch of this very satellite. What over here it also shows us is the increasing importance and collaboration between US and India in strategic spheres also. So what is the main purpose of NISAR? It is basically an observation satellite, and it is going to monitor Earth in a 12-day cycle. It is going to measure Earth's ecosystem and dynamic surfaces. ISRO wants to use it for agriculture mapping, for better agriculture output and climate forecast, monitoring glaciers. As you can know, the recent lake bursts in Uttarakhand, glaciers in Himalayas, and changes in coastline, the impact of increasing global warming with respect to our receding coastlines. So these are the purposes for which ISRO would like to use it for. So the failure of GSLV F10 recently will require an investigation and a thorough review of the failure of this very project, so that this does not repeat when it comes to the launch of NISAR in 2023 on GSLV Mark II technology launch vehicle. So this is all with respect to our today's episode. Stay tuned for our future episodes, and if you like the show, do subscribe and share it. Thank you and have a nice day.